this video, we're going to look at the fundamental theorem of calculus, part 1. You'll note this in the homework when you see a ddx right next to a integral symbol, and you're going to think, what the heck? And don't worry, it gets weirder. The bottom is a number, the top is an x or a function of x. And then we have t's next door. So for example, you could be given ddx, the integral from 1 to x of 2t squared dt. All right, so these problems are weird and students kind of freak out about it, but here is the rule. Basically what happens is that the ddx, the derivative, and the integral symbol are going to cancel out. And that x is going to drop down inside. So my final answer is going to be 2, but instead of a t squared, it's an x squared. Now, are we done? Well, let's think about this. The integral symbol and the dt go together. So once this gets crossed out, this gets crossed out too. Okay, now students panic and go, should I put a plus c? No, because we didn't integrate. What this is that the derivative and the integral canceled out. So you just get the original function back in. All right, let's go ahead and do a couple more, and then I'm going to show you what happens when it's not an x. Okay, so let's do this one's really weird. ddx from 4 to x of cosecant t dt. Okay, again, notice I wrote a 4 here instead of a 1. It doesn't matter what number it is as long as it's a number. These two are going to cancel. Along with that, the x is going to drop inside. So my answer is just cosecant x. No plus c because the derivative and integral canceled. I just get the original back. No extra constant. Okay, now I'm going to show you what happens if the instead of an x, it's got other stuff. All right, so now we're going to look at it when it's not just an x in the top of our integral, it's now an x squared. So the question is, do I just do the same thing? Yes and no, there's going to be an added step. So what happens is that the derivative and the integral will cancel out, and we're going to place an x squared in where we see a t. However, because of chain rule, we have to then multiply our final answer by the derivative of x squared. So what we're going to get is we're going to get 4x squared cubed. However, I have to multiply by the derivative of x squared, and the derivative of x squared is 2x. All right, let's go ahead and clean that up. I don't have to put a plus c on it or anything. So let's see, x squared cubed is x to the 6th. I'll have x to the 7th, and I'll have 8. 8x to the 7th. Beautiful. Okay. All right, how about let's do one more. So here you'll see that my top limit is really funky. It's a sign, and I've got this weird ln(t). So again, what's going to happen is that these two are going to cancel. That's going to go in for t. So I'm going to get the ln of the sine of x. Now, technically, we just have to drop it in, but sine is both positive and negative, so I'm going to throw an absolute value on there. Okay? All right, and then what is the derivative of sine? And the derivative of sine is cosine, and I'm actually going to put that cosine out front so it doesn't get lost in the ln. So it looks like a weird exponent because it's so small. There we go. That's our answer. Okay, now, for those who are curious about why this works, I'm going to have a second video that does a proof. So if you are curious, you can watch it. If you're not and you just want to memorize and use this, that's cool too. Good luck.